we want to continue with learning about electronics and programming electronics for mechatronic. So here we are going to there are concepts that we learned, and we are going to go deep into other concepts. Can you see the screen?
Yes, I can. Yes, I can.
Yes. So we have the hardware, which is the electronic systems. This the motor, the LEDs, the wires, all those, or the electronics. Then IoT, you need to know about these basic concepts. Then also, when you are working as a software engineer or when you are working as a mechatronics engineer, that's why I told you that mechatronics is a cross disciplinary or multidisciplinary. You're going to work with other things. You're going to work with what is called multimeter. Do you know what is multimeter? Do you know what is ammeter?
Yes, yes.
What does ammeter do?
Measures volt.
Current,
Current.
current, current in amps, isn't it? And then voltmeter measures voltage. Okay, voltmeter. You used them in high school, isn't it? Voltmeter.
Yes, yes.
Yes. So voltmeter measures voltage, and then there is also there are three main. We have voltage, we have current, and then the other parameter is resistance. Okay. Do you know this? Voltmeter, ammeter, and then there is also ohmmeter. Ohmmeter. Have you heard of ohms? Ohms? Hello? Have you heard of ohms?
Yeah.
Ohms is the
For measuring.
yes, the measurement for resistance. So there is the equipment is called ohmmeter. So all these three plus other things, they are put together in what is called a multimeter. Okay? Are we together?
Yes.
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 Then oscilloscope. Was there oscilloscope in your high school? I don't think.
Oscilloscope.
Do you know what oscilloscope is?
I feel like I've heard the name before.
Yes. So oscilloscope is also used in an electronics lab. I'm going to show you a picture of how an oscilloscope looks like.
Does it have a connection with oscillations?
Yes, yes.
Okay.
It
I'd
has
say it
a
makes me miss it.
yes, yes. So oscilloscope is used to measure oscillations like sine wave. There is how you produce sine wave, a cosine wave, and then you'll be able to see. Okay, so it's an equipment which is used for measurement. These are measurement. So multimeter is the one which is common. Oscilloscope, you will come across it in your undergraduate studies. And then, do you know soldering gun? Do you know soldering
I've
gun?
heard it.
Yes,
I've never heard it.
yes. I think I should. Yeah, I'm going. Let me just finish this. I show you the pictures. Then there is signal generator. Also, this they are working together. Oscilloscope and the signal generator. Then there is breadboard. Do you see this?
Yes, that's a breadboard. Yes.
Yes, this is a breadboard. Did mom buy those things or she has not bought all of them?
He was supposed to give me the other contact. He didn't.
Ah, okay.
Because
So
our previous contact didn't have
everything.
the Raspberry Pi, didn't have the main parts.
Okay, so okay, so after this we'll talk about that. Then I'll give you the contact. Okay. Then so this is the breadboard, and we are going to learn how to use it. It's used for building the circuit, not really PCB, but it's used to build the circuit. Okay. Are we together?
Yes, yes.
Yes. Then jumper wires. These are jumper wires. These are the jumper wires. They are used to connect components together. So for example, if you have a resistor here, that's a resistor. Do you know the symbol of a resistor? Like this, isn't it?
Yes.
Okay, so that is the resistor. And then if you have an LED, let me just clear. You have a resistor like that. And then you have an LED, light emitting diode, like that. You have an LED, and then that is an LED. So when you want to connect, you saw from the schematic from Walkway when we connected an LED to the Raspberry Pico, isn't it?
Yes.
So we use wires. So here maybe you have got the Pico here, or the Raspberry Pi, or the Arduino here, and then you connect it to through a resistor, and then you connect it to another LED, and then you connect it back here, like to the ground. We did that, isn't it? So this is how the jumper wires. The jumper wires are just wires made out of copper. And then LEDs, you know, these are the LEDs, isn't it?
Yeah.
Yeah, and we've used them last week. So they come in various colors, like this is yellow, this is red, green, the blue. They come in various colors. And do you remember we said that if this is an LED like that, then there is the long and then the short. The long one is
positive.
Is positive. And then the short one is?
That's negative.
Negative. Okay. Yeah. So this is how the LEDs look like. Okay. And then transistors. Do you know what a transistor is?
Not really.
Okay. Okay. Transistor is used to control the flow of current. Do you know a tap? You know water tap, isn't it?
Yeah.
Okay. So what does a water tap do? If I draw
controls the amount of water flowing.
Yes. So this is the tap. Maybe it is in the ground like that, and then water flows here, and you have a bucket, isn't it? Okay. Up here, what do you normally have?
I don't know what to call it. I think
It's
that's
a
the
valve.
tap.
It's called valve.
Well,
Yeah, this is the tap. Okay. This. Okay.
Yeah.
So
Okay.
technically, or what we have something which is called a valve. A valve is just something like this is a if this is anything flowing, you know, if it is a liquid, you know, like water flowing. Okay. Can you see that? Can you see that?
Yes, I can see it.
This is a pipe. Then if you put anything here which can stop the flow of water, can you see that? You block something which can block the flow of water. This is called a valve. Are we together?
Yes.
Yes. So a transistor is itself a valve, but it is not a valve for water, but it's a valve for electric, for current. Okay? Are we together?
Mm.
Yes. So transistor is a valve. It is a valve, but it is used to control the flow of current. All right?
I have a question.
Yes.
How many types of transistors are there?
There are so many types of transistors, but the most common one are PNPN, okay? And then PNP transistors, okay? Are we together?
Yeah.
Yes. So you will learn this in digital, when you are studying digital electronics. And then they have got the technology used to make the transistor. For now, in short, I just want you to know, look at this. I want to show you how a transistor works. I'm going to illustrate it better with the when we go to Walkway. We have got the board. Can you see this? This is Pico. Can you see that? Can you see this? Okay. So Pico operates, the GPIO operates at 12, no, not 12 volts. They operate at 3.3. 3.3 volts. Like if you measure the voltage here, if you measure the voltage here with a voltmeter, then you will find it is 3.3 volts. Are we together? Can you see that?
Yes.
Okay.
Yes.
Okay, then if you take a motor like this motor, if you take this motor, it's a big motor. Okay. And then this motor, for this motor to work, you need 12 volts. Can you see that? Do you see that? 12 volts for the motor to work. Do you think 3.3 can rotate, can turn this motor? Do you think the 3.3 from the Pico can operate this motor?
1 volt. The 11, and that's one.
This is 12. 12 volts.
That's 12.
Yes. And here is 3.3.
No.
No, it cannot. Okay?
Yes.
It cannot do that. So what do we do? We take something, we provide this thing, we provide it with the 12 volts from a different source, from a battery or another battery here, 12 volts. Okay? But before we provide it here, there is what is called, we use what is called a transistor to turn it on and off. So in here, we have what is called a transistor. This is inside here, this, we use what is called a transistor. Can you see that?
Yes.
So this transistor, it has got three, we have got what is called emitter, we have got collector, and then what is called drain. Okay, emitter, collector, drain. Don't worry about this for now. But in short, when you provide small current, when you provide small current here, you provide small current here, then this small current will activate a large current. Let me say if you provide a small current of maybe 0.1 milliamps, can you see that? The small current, 0.1 milliamps. Can you see that? It's very small current. Then the small current can activate a huge amount of current, maybe 2 amps. Can you see this 2 amps?
Yes.
This is very small, 0.0 milliamps, 0.1 milliamps. So it's very small current. When you provide very small current, then it will activate the large current of 2 amps. Can you see that? Yes. And then the motor will rotate, or the motor will work. But then when you turn off this, when you get rid of this, when you switch it off, or when you remove this power, okay, what happens?
The motor doesn't.
When you remove this, or you turn off here, then the current which was activated here is deactivated. Okay?
Yes.
Yes, it is deactivated, and then the motor stops working or stops operating. Okay? So that is what is called a transistor. A transistor is a switch It is a switch used to turn on and off electric current or electric loads. If you have this as what is called the load. And we want to learn what is called output devices. These are output devices, and then input devices, which are sensors. So we have got sensors. Sensors are things like, these ones are used to read. I read it in a wrong way. They are used to read environment variables like temperature, okay, light, okay. We have humidity. All this, wind velocity, all these are environmental variables, or around what is around the environment, the temperature, the humidity, the chemical pH. There is also what pH. Do you remember pH? Potential of hydrogen from chemistry. Do you know pH?
Yeah.
Yeah, pH of a liquid, like acidity or alkalinity of the liquid. So all those can be measured by what is called sensors. Okay, so these ones are input devices or input. So let's go to, before we go to that, so I want us to go to Walkway. Have you opened Walkway?
You 1 minute.
Have you opened it?
Yes.
Okay, so we are going to start by doing a simple. I'm hiding this so that you see. So we are going to start by learning a breadboard. So you come here and then you click on a breadboard. Okay, so these are the components that are there. DHT is light sensor, analog temperature sensor. We have looked at temperature, motion sensor. Okay, there is RTC buzzer. We will learn about all that. Okay, breadboard. So let's start with the breadboard. Do you see this?
Yes.
Yes. So the breadboard has got two lines on the top and two red and blue lines. Can you see this red?
Yes.
Yes, and then this blue. Okay, this red and this blue. So what happens is this one is connected to power. You connect them to power. If you have a battery, you have a battery here, and then the battery, I will use a, I can't use a different color. Don't know whether I can choose a different color. I can't. Okay, like if you, can you see, if you put you connect here, you connect 12 volts positive. Can you see from here? You connect a wire and then it goes to positive. Can you see it is positive?
The upper one is positive.
Yes, the upper
The
one.
upper line.
Yes, the upper line, the red one is positive.
Positive. Yes.
So you connect, if this is your battery, in fact, I've drawn it in a wrong
It's okay.
way.
It's okay.
Okay. So if you have a
Just
battery,
draw the add
yeah,
the plus and minus.
yeah. So this is a battery. This is plus. I think now this one makes more sense, isn't it?
Yes. Yes.
So if you have, you connect here.
To the first part.
Yes. And then you also have here to the,
Oh, it also goes to the first part.
yeah,
Oh, it goes to the
to the blue. Blue, there is red, blue. Can you see this one too?
oh. Okay, I thought it was the up and down. Okay.
Okay, you can also, okay, so these ones work together. Like here, they
The
work
same.
together. You connect them together, okay?
So like both up and down are the same.
Yes, but up is not connected to down. So if you need to connect down also, You can connect another battery or the same. Let's say maybe you have another battery, or you can even just use the same battery. Let me.
So you must connect both wires to the same, either up or down, not
Yes,
separate.
you can connect either of them, any place. Okay.
But they must be in the same.
No, it doesn't.
If
It's not a must. You can even
it's not a
do.
must.
Yeah, it's not a must. Like you can even do this one here.
Okay.
Okay.
It's not a must. Okay.
Yes. And then when you have an LED, you have an LED here. Okay. You have an LED. Let me draw an LED. And then this LED, you connect one here. And then you connect another one here. Do you see that? Can you see that? Can you see?
Yes, I can see.
Yeah. And let's make it this side long so that it comes here. And we said that this one is the positive, isn't it? The long one is the positive, isn't it?
Yeah. The long ones are positive.
And then the short one is negative.
Negative.
Okay. So if you want this LED to turn on, how will we connect it here and here? I want you see this is negative, isn't it?
Yes.
So the negative will be connected to the
Negative.
So I want you to see, can you see this line? The way it is from here to here. Can you see these ones? From up,
The vertical.
from vertically, from up down, eh?
Yes.
They are connected like that. Did you use a breadboard in high school?
Oh.
Yeah?
Nope.
No, okay. But in campus, you'll find them. So if you come here, if I want to connect this negative, if I connect here, okay, do you see this point? Eh? I put a jumper wire and then I bring it here. Okay? Then here,
Yes.
this negative and here are connected. Do you see this?
Oh, there's a wire underneath or something.
Yes, there's a wire underneath. There is those holes, there are holes, but there's a wire underneath. So they are connected.
And
Like
they're connected vertically.
Yeah, they are connected like this, from up vertically, from down, up, down. But these ones are connected like this.
Horizontally.
Do you see that? Okay. These ones are connected horizontally like that. So if you connect here, it's same. Okay. So this one we connect here.
So the jumper cable is basically connecting the low one to that's line, basically.
Yes. So this jumper cable is connecting this one here. It's connecting that. Okay.
So the LED, for the LED to light, the LED should be in the same line.
Yes, they should be in the same line with this one, with this jumper cable.
Okay.
Here, because this was negative, this was positive, sorry. If we take it from here, do you see here?
Yeah.
And then we put it up here.
That should be connected.
Yes. Do you see here? The LED is plugged here. Do you see here? Can you see here?
Yeah.
Then here
The
also.
LED.
This is the LED. So the positive, it has come here. Do you see?
Okay, I have a question. I have a question. I have a question.
Yes.
The LED is the positive of the LED is on a different vertical cable, vertical line.
So if it comes here, let me say the LED comes here, the positive comes here. Do you see that?
Yes.
Okay. Okay. So all this, you see this one, and even this upper one. Do you see this one? This upper one, this one, and this one. They are all connected.
Okay.
So you can take you can use any of them. You use even that one, and then you take it to the positive. Okay.
I've understood.
Yes. Yeah, so that is how breadboard works, and that is what is called breadboarding in short. Okay. Okay, so let's say you want to take a button. We can delete it from here since now we... So to delete this is easy. You click on it and then you delete. So here, a button. So, but first of all, before we start with the button, there are two things here. There is input and output. Okay. Input and output. So if you have got your microcontroller, and in this case, the microcontroller is our Pico, Raspberry Pico. Okay. We are going to include the signal comes from a certain device. Electrical signal comes from a certain device. In this case, we are talking about switch or button. Switch and button is the same. And then it goes out to control another signal, to control another device. In this case, we have an LED. Do you see this? You see this?
Yes.
So we have a switch. So this switch, when you press on it, when you press this, then you are telling it to send a command to the Pico. And then the Pico will process that command. And then it will turn on the LED. You see that? Do you understand that concept?
Repeat once more.
So we have an input or input devices and output devices. So from the input devices produces a signal. A signal is something like this. They produce a signal, electrical signal, okay? And then this signal, when it enters inside a Pico, which is our microcontroller, it goes inside the microcontroller. The microcontroller processes the signal, and then it sends another signal to the output, which is in this case an LED. Do you see that?
Yes.
So the LED will turn on or off. Okay. So
Yes.
the LED in this case is the output. The Pico in this case, the switch here or the button is the input. Okay. So this one produces an electrical signal, and this one receives an electrical signal from the microcontroller. Is that clear?
Yes.
Okay. So the first thing that we want to do is we want to go to this, and then we want to include a button. And this is how a button works. So this side, let us, there is some...
I got the previous project you had.
Yes, the same project that I shared. Do you have it, or I can share with you how it is up to now?
I have it. How
Okay.
it is.
So here, what we are going to do is, the first thing is, one of this and this are connected together. No, this and this are connected. Up and down are connected. Can you see this? Here.
Yes.
And here, they are connected together. But this and this are not connected. So I want you to do this. Take a wire from here and put it to the negative. Can you see here? And I will even give it a color of black. Can you see here? Can you see?
Yes, I can see,
Yes. So here and here, you connect it to negative. Then you take a resistor. Take a resistor.
Can you just use the previous resistor you had there?
Yes, yes. Borrow you.
Like the one that's already there.
Oh, okay. I'll choose another one. So it's going to interfere with this other one. We will move this one a little bit.
We can just delete the other buttons. You can just use like one LED for the time being.
Yeah, can delete them. Okay. So you see this? Do you see it has been connected? You can even put it here. Do you see that? Do you see the resistor? Yes. So which means that this side of the resistor and this side of the button are connected. But this one, we should not put it here. We should put it on this other side. Do you see? Can you see that? Can you see this side is connected like this? Or even I could have even said from here, you connect it here. It has the same meaning because these ones are connected together. Do you see?
Yes.
Let me not confuse you. Let me delete this one. So this side and this side is connected. Okay, here and here is connected. But this side and this side are not connected. Okay, left and right are not connected, but top and bottom are connected. Can you even see here? Can you see this gray line? Tells you that top and the bottom is connected. Top and the bottom is connected. So we use opposite sides. Okay.
Okay. Yeah.
Then we need power. We need power, which was 3.3. Do you see 3.3 volts? Do you see? Do you see that? Can you see 3.3 volts?
Yes, I can see it.
Yes. So we do this and I can give it color red. Normally power, you connect with power red. Okay.
You're connecting it to the...
We are connecting it to this. Don't you see here is plus? And this is plus.
Yes.
Okay.
Yes.
You can connect it this side. Huh?
Okay.
Or even if it's connected here, it doesn't matter.
Okay, my question is, it's all the same. It's all plus. Now the power, okay, we're assuming the power is coming from the Pico.
From the Pico, yes.
That's what we did. But so how do you know if like the power is positive, it's negative? How do you know?
Here, look here. Do you see here?
Yeah.
3.3 volts. So this one is positive 3.3 volts. Ground, GND is ground, is negative. GND is, yes.
Ground is negative and
this other one is 3.3 is positive. Okay?
Yeah, ground.
Okay. That's
so
okay.
Now, okay. So all grounds, like everywhere in the Pico,
yes, it's now connected together.
all grounds are negative.
All grounds are negative. Ground actually means negative. Okay.
And
then 3.3, if you see
positive. Anything else?
Anything else, 3.3 is positive.
Okay, so
actually it has this is the 3.3 volts, it is one. Or leave alone this other one, this one, 3.3, this one. Can you see that?
Those other that's an EN or something.
No, don't work with it. This one, use this one, 3.3 volts. Okay. Is that okay? That okay?
Yeah.
Okay, then we do quickly. Then we connect here. This, the where the resistor ends, you connect it to here. Where the resistor ends here, the resistor you connect it to 3.3 volts. Can you see where the resistor ends? Can you see the resistor?
Yes.
Yes. Okay.
Yeah, I'm gonna put my resistor.
Okay. Then I want us to use a GPIO, like we can use GP2. Can you see 2? Can you see 2?
Yes.
And then we connect it to, we will connect it here to where the 2 meet.
How do you know?
Huh? You can choose any, not that how do you know? You are going to write it in your code. This is GP2. So you are going to write it here in your code, okay?
Okay.
Yeah, so here,
Kind of lost, but
okay, let me do you see where these two are meeting? Where the
okay.
resistor
First,
is?
can you send me your work?
Okay, I'm sending you.
Save first and then send it to me. Like I'm having.
Okay, I'm sending you right now. Okay. Okay, let's take a 10 minutes break and then we continue, okay? Hello? Hello?
Yeah.
Yes. 2 minutes remaining. So let's take a 10 minutes break and then we continue. I've sent you. Can you open the link and you see if it is there? Is that okay?
1 minute. Yeah, it is. It's okay. Yeah, thank you.
Yeah, so let's meet in the next session. Let's meet after 10 minutes break, 9:55. Okay?
Okay.
Yes, then we continue.